things, we have to look at the experimental data and how far they are deviating, whether they are within the acceptable limit or not. Everything we have to consider. So this is not a theoretical questions, it's a practical experimental question. So I have to look at all other issues also. So all of you, please submit your laboratory copy for the first experiment, for the first 3 experiments. Okay, those we have completed. I believe that if any new student admitted, so they may continue for another 1 or 2 days, but you have to be very fast to cope up with the experiment lists. Okay. Okay. So Thevenin and Norton, and maximum power transfer theorem. Now, Thevenin theorem, you're all Thevenin Norton maximum power transfer theorems, I believe. By now, you have got a good understanding of these theorems in your practical, in your theory classes. So I will, this is a very known experiment, and I will not go into the details of the Thevenin theorem, but still it says that in a circuit containing linear impedance and energy source, the current passing through a load impedance is same as a single supplied by a voltage source of EMF VTH and internal impedance ZTH. Okay, so this will be our experimental circuit, and this is a Wheatstone bridge kind of circuit, and the load resistance RL is connected between the points C and A, and we will measure the current IL flowing through this load resistance RL. On the other hand, this V in is a supply voltage. Okay, so V in is the supply voltage. Now for this particular circuit, the linear impedances are there. That means all we take that resistive circuits. So it is a linear circuits, and also the Thevenin theorems is applicable for capacitives and capacitive and inductive circuits also, but we don't go into the nonlinear aspect of those devices. We also consider that devices to be linear devices. Okay. Now for this Wheatstone bridge resistive circuit, this circuit can equivalently be thought of as a simple circuits, which is an equivalent circuit of this particular experimental circuit to be a simple circuit consisting of a voltage source VTH, a resistance RTH, and this load resistance RL. Okay, where VTH, this VTH is the equivalent voltage source across these load terminals. So this VTH is the equivalent Thevenin voltage or equivalent voltage when that appears across the load terminal. Okay, open circuit voltage. Open circuit means you just turn off this circuit, মানে এটা খুলে নেওয়া যেটাকে বলে আমরা, with a high impedance. So and find out that what is the voltage appearing across the load resistance. তাহলে load resistance এর মধ্যে যে ভোল্টেজটা আমরা পাবো এবং লোড রেজিস্ট্যান্সটাকে খুলে দিতে হবে, ওপেন সার্কিট করে দিচ্ছি। ওকে, সো ইট ইজ বিং মেড ওপেন। তাহলে সার্কিটটা ওপেন করে দিলাম, ওপেন করে দিয়ে আমার যেই ভোল্টেজ, তাহলে আরএলটা যখন খুলে নিয়ে আমি যে ভোল্টেজ ড্রপটা এই টার্মিনাল গুলোর অ্যাক্রসে পাচ্ছি সেইটাকে আমরা বলছি দ্যাট ইজ দ্য থেভেনিন ভোল্টেজ। On the other hand, there is also an equivalent resistance. So this equivalent resistance, how we will get this equivalent resistance is the resistance when we short circuit this voltage source. The voltage source is short circuited. Now actually the voltage source to be replaced by its ideal impedance. Now this ideal impedance for a voltage source is always 0, and therefore this voltage source to be used as a short circuit. Okay, now you find out,
yes sir,
now you find out the equivalent resistance that you can see from this terminal. এই টার্মিনাল থেকে যে রেজিস্ট্যান্সটা তুমি দেখতে পাচ্ছ when these 2 points are shorted together. And that means when A and B, this is shorted together, then you find out the resistance that can be seen from this terminal, from these 2 terminals. Okay, so that is your equivalent resistance, and RL is the load resistance. So this is the concepts of Thevenin theorems and Thevenin equivalent source and Thevenin equivalent resistance. Now if I have this simple circuit, then it's a very interesting, it's a very simple to write down the formulas as IL, if IL be the load current, then IL multiplied by RTH plus RL is equal to VTH. That is IL into RTH plus RL is equal to VTH. And therefore, if I express this VL, the VL can be written as VTH minus IL into RTH. Okay, and now I see that the relationship between this VL load voltage and the load current is therefore a straight line. It can be expressed as Y is equal to mx plus c, where m is the slope, and the slope is turned out to be minus RTH, and the intercept on the y-axis is c, and c is equal to VTH. So if I consider y is equal to VL and x is equal to IL, then I write down this VL is equal to VTH minus IL RTH equations as y is equal to mx plus c. And also this IL is actually the load voltage by the load resistance. So these types of plot we can get where I plot VL along y-axis and IL along the x-axis. So this slope will give you minus RTH, and the intercept on this y-axis will give you the voltage VTH. So that is the basic theory of my problem. Now then, how we will do this experiment? So I set up this circuit in the form of the Wheatstone bridge, and we change certain different values of RL. Okay, so keeping the V in, keeping the input voltage to a convenient value fixed. I keep this V in fixed, and then I change various RL. I change different RL, and I measure the voltage VL through a voltmeter, and we calculate the ammeter current or this can be calculated in two ways. Either you can use an ammeter in series with this load resistance, or if you do not have these ammeters, then if you have the load voltage VL, then VL by RL will give you the current flowing through this resistance. Okay, then it's very simple experiment. Then you plot the VL versus IL graph, and you can easily extract the RTH as well as the VTH value. একটু আমাকে আমি একটু পজ করছি, হ্যাঁ। আচ্ছা সরি, যেটা আমরা শুনতে পাচ্ছ?
ইয়েস স্যার।
হ্যাঁ, তাহলে এই খুব সহজ ব্যাপারটা বোঝা গেল যে আমরা বিভিন্ন লোড রেজিস্ট্যান্স নিয়ে ভিএল আর আইএলটা মাপছি, মাপার পরে ওইটা প্লট থেকে আমরা এক্সট্রাক্ট করতে পারছি। ঠিক আছে, at the same time you can also measure the open circuit voltage CD টার্মিনালের across keeping V in constant। তোমরা V in তাহলে আমরা যদি ওইটাকে খুলে নি, if I open the load resistance then also I can directly measures the open circuit voltage। ঠিক আছে, and after removing the we can also then, তার মানে একবার আমরা গ্রাফ থেকে বার করছি আর আরেকবার আমরা এক্সপেরিমেন্টালি এখান থেকে এইটাকে খুলে we can measure after opening this resistance RL, so we can directly measure the potential across this. Okay, and similarly I can also short circuit the terminals AB, and after short circuiting this terminal I can also find out the resistance RL directly through a multimeter, and then I compare that between the results that I get between this from this graph as well as by direct measurement। ঠিক আছে, so that is your বোঝা গেল। এটা হচ্ছে সাপ্লাই লোড রেজিস্ট্যান্স রেডি করিয়ে সাপ্লাই ভোল্টেজ চেঞ্জ করবে, দিয়ে মিনটা বার করবে, করে সেটা এই গ্রাফটা করবে, সেখান থেকে ইন্টারসেকশন নেবে, স্লোপটা বার করবে। হ্যাঁ, আবার ভেরিফিকেশনস ভিএলও ফ্রম টেবিল থেকে পাবে দুটো, তাহলে টেবিল থেকে তোমার আরটিএইচ ভিটিএইচ এগুলো পাবে, আবার তুমি এক্সপেরিমেন্টালি যেই ভ্যালুগুলো মেজার করেছো সেটা তুমি নিয়ে ট্যালি করবে। সো দ্যাট ইজ ইয়োর ডিটেলসটা তোমাকে করার সময় দেবব্রত স্যার বাকিটা বলে দেবেন। তাহলে বোঝা গেল থেভেনিন থিওরেমের এক্সপেরিমেন্টটা। ইটস আ ভেরি সিম্পল এক্সপেরিমেন্ট।
ইয়েস স্যার।
স্যার প্র্যাকটিক্যালি শর্ট সার্কিট কিভাবে করব?
সেগুলো সব কালকে গিয়ে দেখবে, তোমরা এক্সপেরিমেন্ট করার সময় দেখবে।
ওকে স্যার,
ঠিক আছে। Okay, then I go to this Norton's theorem. Norton theorem is also very simple. There is a counterpart of this Thevenin theorem, and in Norton theorem the case is that it is an ideal equivalent current source and in parallel with a resistance which is Norton resistance. So this where the current source in parallel with this impedance RS or ZS, and this ISH is the shunt or the short circuit current at the load terminals RL। তাহলে আমরা এখানে কি পাচ্ছি যে ভোল্টেজ সোর্স যখন বার করেছিলাম it is an open circuit voltage source, on the other hand when we measure the short circuit current, so if I get a short circuit এখান থেকে যদি আমাদের এখান থেকে, so short circuit is basically a low impedance। okay, if it's a very low impedance or a zero impedance then it comes to be a short circuit, and if it's a very high resistance then it is actually a open circuit। okay, so as I do this short circuit, if the load resistance is short circuit and then the current flowing through this load resistance will give you the equivalent Norton current, and the Thevenin the Norton resistance is similar to the Thevenin resistance. Norton resistance is the impedance of the circuit looking back from the terminals when the energy sources are replaced by their internal impedance. So internal impedance means, so in this case also this V in will be shorted because V in as an ideal impedance, internal impedance is equal to 0. So the resistance, the Norton resistance is basically same as the Thevenin resistance, and you measure the short circuit current flowing through the circuit, flowing through the load resistance. So the equivalent circuit network for this Norton equivalent circuit will be like this one. Now it is very simple to derive that this I short circuit is equal to the current flowing through this resistance RS plus the current flowing through the load, that is IL. Now after a simplifications, I write that this load current IL is equal to ISH minus VL by RS. Now this can also be written in linear equations. If I say that y is equal to IL and x is equal to VL, then I can write it as a y is equal to mx plus c, where c is the short circuit current, and the slope m is equal to minus 1 by rs is the series resistance, okay, which is the equivalent resistance. So very similar to our earlier graphs, I can, if I plot IL versus VL, then from this plot you can also, this graph will be very similar. The slope will give you minus 1 by rs, and the intercept in the y-axis will give you ISH. Okay, so the procedures is more or less very similar to what you followed for this Thevenin resistance. You set up the circuit and you keep the V into a constant voltage of say 10 volt, and keep the voltage, you have to keep the voltage constant throughout the experiment. Then you measure the series current RL, that is the IL. Then you change the various values of RL and you get the IL versus VL data, and you find out the value of ISH and RSH from the graph. And also you can directly measure after short circuiting the load terminal CD. So after you short circuiting the load terminals, you take the DC milliammeter and find out the value of the short circuit current. And also you have in our Thevenin Shomoy, you have find out the equivalent resistance. So here also you find out the value of ISH from graph as well as from your direct short circuit result, and you compare, and you also compare the value of the Norton resistance. So that verifies your Thevenin's and Norton theorem. Okay. Now the next part of this experiment is the maximum power transfer theorem. So this maximum power theorems, it is a resistive circuit. The circuit will be shown in the experimental board. You know that if the load resistance is varied, then the maximum power will be absorbed. You know there is a transfer of power from this power supply to the load, and the maximum power that will be absorbed by the load resistance is equal to the internal resistance. So internal resistance means it's a Thevenin equivalent resistance of the source network as seen from the load terminal. Okay, so the power is given by this types of formula, P is equal to V square by RL, and in this experiment you have to use different values of RL. Different values of RL tumi jodi now, and you calculate the power across the power dissipations across this load resistance, P is equal to VL square by RL. And then if you plot a graph like this P versus RL, then you will see that the value of the resistance, the maximum value will be equal to the Thevenin resistance. So which is equal to the internal impedance plus the Thevenin resistance. But since the internal resistance of the regulated power supply is equal to 0, then the output resistance will be equal to the Thevenin resistance. So at this particular value, এই আরোর এই ভ্যালুটা আমরা এখান থেকে পাবো যেই ভ্যালুতে পাওয়ারটা ম্যাক্সিমাম, and you verify that this comes out to be the value of the Thevenin resistance. ঠিক আছে? So the value of RL at which the power is maximum will be find out to maximum value comes out when it is equal to the Thevenin resistance. So this completes your maximum power transfer theorem. এরপরে যখন তোমরা when you will do these experiments, your sir will give you the detailed instructions about how to operate in the board. বোর্ডটা কিভাবে কাজ করবে, কত ভ্যালু নেবে, কত রেজিস্ট্যান্স নেবে, কিভাবে চেঞ্জ করবে, সেটা সব তোমরা এক্সপেরিমেন্টাল যখন করবে তখন সেটা দেখতে পাবে। ঠিক আছে, তাও একবার মোটামুটি বলে দেয়, সহজ এক্সপেরিমেন্ট একবার ডিসকাস করে দিলাম, নিজেরা পড়ে আসবে ভালো করে। ইউ ডু দিস থিংস, ইউ রিড দ্য Chattopadhyay Rohit's book, and I will appreciate that if in your discussions, if you find out the VTH and RTH values theoretically, okay, for this particular Wheatstone bridge network. So if you do these analytical calculations and find out the VTH and RTH, and then in your discussions you may compare that what is the theoretical value that you find out for this particular experiment. তোমরা PQRS এর ভ্যালু গুলো সব পেয়ে যাবে। কোন একটা যে কোনো একটা PQRS এর অনেকগুলো হয়তো না, কটা সেট করতে হয় জানি না, সেটা স্যার বলে দেবেন। কোন একটা সেটের জন্য PQRS এর ভ্যালু গুলো নিয়ে যদি VTH আর RTH এর অঙ্কটা করে VTH আর RTH এর ফর্মুলায় বসিয়ে একবার দেখবে how the theoretical formula matches with your experimental data. So these things you can add in your discussion sections. That will be a very good exercise to compare the theoretical results with the practical values. Okay?
Yes, sir.
ঠিক আছে, এটা তারপরে করে ফেলবে। আর একটা এক্সপেরিমেন্ট আমাদের যাই না, কালকে হয়তো তোমাদের সবকটা এক্সপেরিমেন্ট আর থিওরি আলোচনা করা যায় না, আজকে 8:30 বেজেও গেল। হ্যাঁ, সো next things we will discuss another experiment on attenuator, and that will complete the our course on hands-on. Okay, practically এই 5টা এক্সপেরিমেন্ট আমাদের করা থাকলো। 3টে, একটা LR এক্সপেরিমেন্ট, CR এক্সপেরিমেন্ট, LCR রেজোনেন্স এক্সপেরিমেন্ট, দেন থেভেনিন নর্টন থিওরেম ম্যাক্সিমাম পাওয়ার ট্রান্সফার, এটা একটা এক্সপেরিমেন্ট। আর নেক্সট দিন আমরা ডিসকাস করব which is on the attenuator experiment. ওকে, কালকে হয়তো অ্যাটিনিউয়েটর এক্সপেরিমেন্টও করতে হতে পারে কিন্তু। সো বি প্রিপেয়ার্ড উইথ দ্য ম্যানুয়ালগুলো সব পেয়ে গেছো নিশ্চয়ই তোমরা?
হ্যাঁ স্যার, ক্লাসরুমে আছে।
হ্যাঁ, তাহলে সেই অনুযায়ী তোমরা এটা করবে। ঠিক আছে, ঠিক আছে তাহলে। ওকে, সো আই এম জাস্ট লিভিং দিস ক্লাস।
ওকে স্যার, থ্যাংক ইউ।
থ্যাংক ইউ, গুড নাইট।